All right, Unit 5 review. We're going to start working through these problems, so please follow along with your review guide. All right, first off, describe each as exponential growth or decay. If we're looking at these, we just need to look at the base. So if the base is 2/3, I know that's less than 1, which would mean decay. Okay, if the base is bigger than 1, like it is right here, 6/5, that's going to be growth. Okay, do not look at the front value. The A value, that does not tell you. Okay, that's just vertical stretch or vertical compression. So do not look at that to see if it's decaying or growing. Just look at the bases. Okay, less than 1 decay, bigger than 1 growth. Here we go. Graphing. Starting with exponentials. So we know that if we have an exponential, we want to start these off by finding our asymptote. Okay, the asymptote is going to be the K value, and it is going to be a horizontal asymptote. So y equals -6. We're not going to have a vertical asymptote. We'll go over, draw that on my graph here. Okay, now it's time to start making a table. To start this table, my middle point, I just want to set my exponent equal to 0. So x plus 1 equals 0. I know that that tells me x is -1, so that's going to be that middle point. Okay, I need 2 points to the left of that and 2 points to the right. So -2, -3, 0, and 1. Then I plug those into my calculator, and this is what I should get out. -5.8 repeating, -5.6 repeating. I'm just going to go ahead and just round them as they are. -5, -3, and +3. Okay, good deal. So now I go and I plot these points. -3, -5.8, -2, -5.6, 0, -3, and 1, 3. So this is going to be an exponential growth one, which I knew that was going to happen because my base was 3. Okay. Should look something like that. Ignore that bell ringing in the background. Okay, so if I look at this domain, so from the left to the right, this is going to go from -infinity to +infinity. Range, so from bottom to top, this is starting at that asymptote at -6 and going to infinity. Limits, I know that I just copy down my domain right here. As x goes to the left, I can tell that y is going to stop at that wall or that asymptote. So that is at -6. And then as x goes to the right, y is going up forever. Call that infinity. We already said this one's increasing, so I'm just going to copy that domain down, write none on the decreasing line. X-intercept, y-intercept. So I can tell this is definitely going to cross the x-axis, but unfortunately my table does not give me that point. It does give me the y-intercept though, so that was nice. Okay, but to find that x-intercept, I know that that's when y equals 0. So I'm going to go up here, and I'm going to plug in 0 for y, or f of x. They mean the same thing. Okay, I get this. I know when I'm solving an exponential, I need the base and its exponent on a side by itself, so I can't have this -6 over here. I'm going to add it over. So we get 6 equals 3 to the x plus 1 power. Set up my log. My base is 3. Of 6 equals x plus 1. I can type in log base 3 of 6 in my calculator by just typing in log of 6, close parenthesis, divided by log of 3. Log A divided by log B. I get 1.63 with a decimal that keeps going. I know I've got to subtract that 1 over, so I end up with x equaling 0.63. So that is how I get that. 0.63, 0, and that is it. Okay, another exponential one, number 4. We go ahead. Our asymptote is y equals 2. We don't have a vertical asymptote. There we go. Okay, start my table. I need to set this equal to 0. I know that's going to be 5. And then 2 numbers to the left of that, to the right. Plug them in, and when I plug these in with my calculator, I should get 6, 4, 3, 2.5, and 2.25. I go and I plot these, so 3, 6, 4, 4, 5, 3, 6, 2.5, and 7, 2.25. And I get a graph that looks like this, okay? Looks like a decay one, right? Which makes sense because the base was 1/2. It's still gonna have a domain of negative infinity, positive infinity. It's going left forever, right forever. From bottom to top, this one's starting at that asymptote of 2 and going to infinity. Rewrite my domain here. As x goes to the left, y is going up to infinity. As x goes to the right, y is stopping at that wall, which is at 2 this time. Okay, left to right, we said this one is decreasing, so we rewrite that domain there and put none on increasing. If I look, this thing is never going to cross the x-axis, and if I try to set up an equation like I did in the last one, you're going to get an undefined answer, so it's not going to work. There's not going to be an x-intercept on this one, but y-intercept, we know that eventually this is going to cross the y-axis, but we don't know where yet. But we can find that just by plugging in 0 for x. So I plug in my calculator, 1/2 caret to the 0 minus 5 power, close parenthesis, add 2. And when you do that, you should get 34. So that's going to be way off my graph, but it is the intercept. So we'll go ahead and write that down. Okay, moving along. We have log graphs now. Okay, these are inverses of exponentials, so it's really, really important that you know the difference between the two. You practice this, you do your homework, and you do a little bit of extra practice if the homework didn't make sense, okay? Go back, watch the videos, whatever you gotta do. Make sure you know how to do both types of graphing and how to do them well, okay? So when we are starting a logarithm graph out, okay, we know that this time there's not going to be a horizontal asymptote, okay? Instead, there's going to be a vertical asymptote. Well, how do I find that? We need to find the a value of the log and set that equal to 0. So in this case, it's just x. X is 0. So that's going to be my asymptote. That's going to be my undefined point. So it's going to be the equation x equals 0. If I plot that, it's going to be right on that y-axis. Okay, so then we want to go ahead and we want to start plugging in points. So we'll plug in points to the right of 0. We don't need to go anything less than 0 because we know that's still going to be undefined. We'll do 1, 2, 3. We could even do like a fraction 1, 2 if we want to, which is what you'll find on the answer key of the review. So when we go and we plug these numbers in, when we get 1, we get -3 out, 2, -4, 3, -4.58, and then when they typed in 1/2, they got -2, which is fine. You could also do something bigger. I'm actually going to change this number. I'm going to do like 8 and see what I get for that. Okay, so when I go and I plug this in, negative, how I would type this into my calculator too, so that's important. If you struggle with these, again, when you're doing that change of base formula, it's log A divided by log B. We said the A value was X, so when I go to type this in, negative log parentheses whatever the x is that you're typing in, so in this case it's 8, so negative log 8 close parenthesis divided by log of 2 close parenthesis minus 3, and I get -6. So that's what I get for that. And now I'm just going to go plot these points. So 1, -3, 2, -4, 3, -4.58, and 8, -6. Okay. The reason that they plugged in 1/2 on their graph was just to see what this did as it got closer to this asymptote. We know it's going to approach that asymptote. So it should look something along the lines of this. We know that this one is not going to be negative infinity, positive infinity for domain. However, it will be that for range. It goes up and down forever. But for domain, it looks like we're starting at that wall, which we said was at 0. We're going to infinity. So for the limits, we rewrite that domain down here. As x is approaching that wall, it looks like y is going up forever. So that's infinity. And then as x is going to the right, getting away from that wall, y is going down forever. If we follow this arrow from the left to the right, this is a decreasing one, so we'll rewrite the domain there. We'll put none on increasing. For x-intercepts, we know that is when y equals 0. So if I look at this one, I don't have that in my table, so I'm going to have to set up an equation for this one. So we will do that. So 0 equals negative log base 2 of x minus 3. I know that I need that log base and a value on a side by itself. This 3 cannot be over there, and that negative 1 cannot be in front. So I'm going to have 3 equals this, then I'm going to divide by negative 1, okay? When I do that, I end up with, I'm going to go over here so I have more room, negative 3 equals log base 2 of x. So now I'm able to set this up. My base is 2. The negative third power equals x. If I type that in, 2 caret negative 3, enter, I get x equals 0.125, comma 0. And then for the y-intercept, none, right? That's our asymptote. We're going to cross that y-axis. Next one. Natural log, same thing. These are actually just a little bit easier to type into the calculator, which is nice. Don't have to do that change of base formula. So we go ahead, we start this one off. We know that we need to set this equal to 0. That's going to give us negative 4 for our starting point, and also for the asymptote. We know it's vertical. Okay, so things that are bigger than negative 4, we'll do negative 3, negative 2, negative 1, and I'm going to do something a little bigger. I'm actually going to do 8, just so I can see what this does at the very end of my graph that I have here. I know that this goes to 8, so I want to know what it does that far. So we'll go ahead, we'll plug these in. When we type them in just as they look. Natural log parenthesis, type in the negative 3, plus 4, close parenthesis, plus 2, enter. You should get 2, okay? When you go back and change that to a negative 2, you should get 2.7. For negative 1, you should get 3.1. And then when I go change that to an 8, I get 4.5, rounding. Okay, so now we go and we plug these in, or plot them, I mean. And then 8, 4.5, so that tells me this is going to curve out like this and then shrink down towards that asymptote. So it should look something like this. We look, our domain is going to be from that wall, which is at negative 4 to infinity. Range is negative infinity, positive infinity. Rewrite that domain. Okay, y is going to, as we approach negative 4, y is going down. So we can see as x goes left, y is going down here. And then as x goes to the right, y is going up. This is an increasing one, so we'll copy down that domain, write none on decreasing. We look for x-intercept. Yes, we're crossing the x-axis. No, it's not in our table, so we do have to set this one up. 0 equals natural log of x plus 4 plus 2. Got to have the natural log and its a value by itself. Subtract that 2 over. Now we can set up our exponential. We know that since it's a natural log, it's a base of e to the negative 2 equals x plus 4. When I type in my calculator, e to the negative 2, hit enter, I get 0.1353, keeps going. I know that I'm then going to have to subtract 4 from that number, so I'm going to go ahead and do that in my calculator. And I get negative 3.864, and it keeps on going. So we'll just call that negative 3.86, comma 0. And then for y values, unfortunately, that's not in my table either, but that one's a little easier to plug in. Just like a table point, I just plug in 0 for x. So I go natural log of 0 plus 4, close parenthesis, plus 2 equals 3.39 is what I'll round it to. Okay, cool. That's how we do it. Let me know if you got questions on that. Okay. Keep going. Convert between exponential and logarithmic forms. So this is super easy. You don't have to do any solving if the directions just say to convert. Okay? So what it means by this, log my base is 8 of 64 equals that exponent of 2. Okay, log my base is 10 of 54 equals 2x. Again, we're not solving, it just says convert. Okay, we won't solve until it says to solve. We'll finish up all of these exponentials. So log base 2 of 32 equals x minus 4. Okay, we see a base of e on this one, so that tells me this is going to be a natural log 1. Natural log of x minus 2 equals 6. Cool. And now going back and forth between the exponential form, we can see here our base is 3 to the third power equals 27. X to the 1/2 power equals 7. 4 to the x power equals 90. And, natural log, that means base of e, right? So e to the 30th power equals x. Cool. Now it's saying to evaluate. Okay, so this is when we actually do have to evaluate. The first part says do not use a calculator. Yes, you can use a calculator on the test. So if you're evaluating these with a calculator, it'd go a lot faster. So I would recommend doing that, or at least checking yourself if you want to do it by hand. But if I was doing it by hand, I'd set it up like this. Well, if I think about it, 9 squared is 81, so x would equal 2. Okay, 5 to what power is going to be 1 over 25? Well, I know 5 squared is 25, and to make that go down to the bottom of my fraction, it needs to be a negative square, so negative 2. Then we got 81 to what power is going to be 3. Okay, so we got to think about that one. That one's a little bit trickier. But if I think about my knowledge of square roots and cube roots, if I cube root 81, that's actually not going to be 3, but if I do 4 through 81, that's going to be 3. Don't expect you to know that in your head. Again, if you were checking this in the calculator, you'd type in log 3 divided by log 81. And when you do that, you'll end up finding out that if I 4 through to 81, I'd get 1/3, or sorry, I'd get 3. So that is x to the 1/4 power. But again, typing in log 3, close parenthesis, divided by log of 81, you'll get 0.25, which is the same thing. Okay, and then 6 to what power equals 1? That's an easy one. We know anything to the 0 power equals 1. So next up, evaluate using a calculator. So again, make sure you use it. So if I'm typing in log 63, I can just type that one right into my calculator. I know it's got a base of 10, and that's what my calculator is made for. So 1.799. Doesn't even say how you should round it, so just do whatever you feel. 1.799, 1.8 would work too. I would say on these, the more decimal places, the better though. So maybe just like 3 or 4. When we go to 20, I would type in log base, again, a divided by log base b, so log of 95, close parenthesis, divided by log 7. And I get 2.340. Cool. And then log of 78 divided by log 2, 6.285, that works. And natural log of 42, do not type log. This is a natural log one. You have a different button for that. Natural log 42, enter. 3.73. Okay, we'll round that up. So, good deal. That is how we do those. Next up, condensing or expanding. Okay, so we can tell just by looking at these that the first 3 are condensing and then the next 3 are expanding. Okay, so when we're condensing, we know the first thing we do is we look at that power rule. Okay, we got to move those to your a value, right? So that's the same thing as log base 2 to the 3rd power plus log of x minus 4. Again, we start with power rule. Okay. Once we have done that, now we need to get rid of this plus sign, okay? So we can condense. We know that the logs have the same bases of 10, which we don't have to write. Plus sign means to multiply. So log of 2/3 times x minus 4. So 2 to the 3rd, we'll go ahead and evaluate that. Gives us 8. Log of 8 times x minus 4. I'm going to run out of room here really fast. Okay, so we can just distribute out that 8, and we'll leave it just like that. Okay, so that is how we condense. Same thing over here. This 1/2 is going to this guy. So log base 5 of 324 to the 1/2 power minus log base 5 of 2, well, 324 to the 1/2 power. I can type that in, and I get 18. So this is log base 5 of 18 minus log base 5 of 2. Got to get rid of the subtraction sign. I know I changed that to division, so I keep my same base, and I do 18 divided by 2, which I know is log base 5 of 9. Okay, that's it. Another power rule, and another one. Okay, natural logs rules are still the same. So 6 to the 3rd minus natural log of 4 to the 3/2. We'll go ahead and simplify those numbers. 6 to the 3rd is 216. 4 to the 3/2 power is 8. Okay, and now we must change that subtraction sign to division. 216 divided by 8. 216 divided by 8 is 27. So this is natural log of 27. Leave it like that. Don't have to evaluate it. Okay. Next up, we've got expanding. So this works in reverse order. Okay. So what we want to do, we have this 3 out front. I cannot start breaking apart what's in those parentheses until I distribute this 3 out. So when I do that, I get log base 3 of 9 to the 3rd, x to the 6th, because again we multiply powers, y to the 15th. Okay, now I'm able to start breaking this apart. So first things first, I know I'm multiplying inside here, so I know that that goes with addition. Log base 3 of 9 to the 3rd plus log base 3 of x to the 6th plus log base y to the, log base 3 of y to the 15th. Okay, so that is how I expand it, but now I've got to take those powers, move them to the front, okay? Because again, that is how we expand. So when I do that, I'm going to go write it over here so I have more room. 3 log base 3 of 9 plus 6 log base 3 of x plus 15 log base 3 of y. Okay, and that is how we do a problem like this. Okay, one thing too, if you saw this before we expanded it, so it was log base 3 of 9 to the 3rd, and we know that 9 to the 3rd power is 729. I could go ahead and try to evaluate this one since it is all numbers with no variables. So I could just type in log of 729, close parenthesis, divided by log of 3, and I get 6. Okay, so this is the same thing as 6. So that only works again when there's no variables in the problem. We can go ahead and simplify that out to get 6. So that would be the final answer there. Okay, and we know how to evaluate this. So make sure we do that if we see it. Okay, same deal here. We've got to make sure that we distribute out that power. So this is going to be the same thing as natural log of 2 to the 4th over 5 to the 4th, a to the 12th. Okay, now we got division. We know we got to separate that by subtraction, so we'll have natural log of 2 to the 4th minus natural log of 5 to the 4th. And this would actually be a plus because we're multiplying that denominator together, a to the 12th. Okay, we'll have to distribute out that negative for our next step, and we can also go ahead and move those powers to the front for this as well. But since we have numbers, we could go ahead and evaluate this too. So 2 to the 4th power, you could write it as 4 natural log of 2, or you could just put natural log of 16, because we know that's the same thing. Okay, minus natural log of 5 to the 4th, so I could put minus 4 natural log of 5, which is Totally fine to do. I think that's what it says on the answer key. You could also just go ahead and evaluate 5 to the 4th power, which would be 625. So just do minus natural log of 625, okay? And then, again, we're distributing out this negative, so we're going to have another minus 12 natural log of a. You can't do anything with that, because, again, that's got a variable in it. So that's it. And then we've got this guy right here. Okay, the big thing to remember here is that when we see a root, that's the same thing as a fractional exponent. So since this is a square root, it's the same thing as the 1/2 power, okay? So that is the biggest thing to remember on this one. And then we are just distributing that power out to each of these components first before we expand this. So log base 4 of 4 to the 1/2, p to the 3/2, q to the 10/2. Okay? And now we can break this apart with addition. So log base 4 of 4 to the 1/2. Well, 4 to the 1/2 power is just the square root of 4, which is 2. So log base 4 of 2. It's fine to leave it like that. Plus log base 4 of p to the 3/2 plus log base 4 of q to the 5th, right? We can simplify 10 over 2 to the 5th power. Cool. And then lastly, we just need to move those power rules. Since this one is numerical, you could go ahead and see if that one will work out, or just type it in your calculator, log 2 divided by log 4, and you will end up getting 1/2 for that one. If you leave it like log base 4 of 2 written like that, that's fine, because you showed me that you know how to expand that, so I'm not worried about if you evaluate it or not. But this technically would be the simplest form. So log base 4 of p, and then plus 5 log base 4 of q. That's it. All right, fun stuff now. Solving equations and then checking for extraneous solutions. So the easiest ones are when we have logs on both sides, okay, and they have the same base. We make sure that we have one log on each side, so meaning we condense each side, which in this case it's already done for me. So I'm able to just set those a values equal to each other and solve. So these ones work out pretty darn easy. Subtract that 7 over. So 3x equals 24, divide by 3, x equals 8. Lastly, I just want to go check and plug in that 8 everywhere where there's an x, make sure I don't get any negative values, and I don't, so I'm good to go on that one. Okay, number 30, same deal, these are already condensed, they have the same base, so I'm ready to set up my equation. I want everything on one side, so I'm going to subtract the 6p over, also subtract the 18 over. So I get p squared minus 7p minus 18 equals 0. This one's going to be an x method one. 1 times negative 18 is negative 18. Negative 7 on bottom. Two things that will multiply to give me negative 18, but add to give me negative 7. I know the numbers are going to be 9 and 2, but 9 needs to be negative. Okay. So p plus 9, p minus 9. P plus 2 equals 0. Set both terms equal to 0, and I get p equaling 9 and negative 2. So if I go and I plug both of those things in, I know that the 9 is going to work on both. The negative 2 squared is going to be 4 minus a negative 2. That's still going to be positive, so we're golden on that. All right. Next up, number 31. So again, when we're solving these, we notice on this one we've got 2 logs on the left, 1 log on the right. So I can't have 2 on the left, I need to condense those. So I'm going to use what I know about condensing, which we just did, to solve this one. So first things first, move the powers to the back. So log base 8 of 36 to the 1/2 plus log base 8 of 3k plus 7. Cool. 36 to the 1/2 power is 6, right? Square root of 36 is 6, so I can go ahead and combine these now. Since I'm adding, I'm going to change this to multiplication. So 6 times 3k plus 7 equals that right side. Okay, now I have one log on each side. It's condensed, so I'm able to just go ahead and set those a values equal to each other. So I've got 6 times 3k plus 7 on the left. I'll go ahead and just distribute that out. Get 18k plus 42 equals 132. Subtract that 42 over, so I get 18k equals, what is this going to be, 90, and then 90 divided by 18 is 5, so k equals 5. Go plug that back in, and that's going to be a positive a value, so I'm good on that. 32, same deal, okay, I don't have a condensed log on the left. It looks like I've still got a power out front, so I need to move that over. On the right, not condensed, right? So I need to combine those since it is subtraction. That means do division. So 20 divided by 5, which I know is 4. Okay, so now I have this. I'll go ahead and FOIL out y plus 5, y plus 5. So y squared plus 5y plus 5y plus 25 equals 4. Combine like terms and subtract over that 4. X method. Okay, two things that multiply to 21, add to 10, 7 and 3. Y plus 7, y plus 3 equals 0. Set them both equal to 0. Y is going to be -7 and -3. Okay, so then what we want to do is we just want to double check both of those. If I plug in a -7 right here, -7 plus 5 is -2. I can't take the log of -2 because that's undefined, so that's not going to work. But if I plug in a -3 right there, that's still going to give me a positive number. So I'm good on -3, but -7 is not going to work. All right, and then we keep going. We notice on this one that there's a log on the left, but not one on the right. So this is different. Okay, this is when we must set up our exponentials to solve. So I want the whole log with its base and a value on the left, nothing else, and everything else on the right. So it looks like this one's set up for me. So I take that base, put my power, set it equal to the a value, and then I just evaluate. So 2 to the 7th is 128. 128 minus 2, and then divide by 9. And m is 14. Go plug it back in, make sure it's positive, and it is. Okay, natural log is not on a side by itself. I must move this 5 over. Now I'm ready to set it up. Base of e to the 3rd power equals 2a minus 1. E to the 3rd power, we'll round it to 20.09 equals 2a minus 1. So, add that 1 over. So I'm just going to type in 1 plus 1 to my calculator. Then I know I have to divide that by 2. I end up with a equaling about, depending on how you rounded it, about 10.54. Okay. Good deal. All right, now we got exponentials. We must have the same base on each side in order to set the exponents equal to each other. I notice here I don't have that. Okay, so I look at the two numbers, 64 and 4, which one is smaller? 4. So I go out and I start writing the powers of 4. 4 squared is 16. 4 to the 3rd is 64. Heck yeah, got both numbers. Okay, cool. So now I just change the 64 to 4 to the 3rd. Cool. So now I'm able to set their exponents equal to each other. So I got 3 times x plus 7 equals 4x minus 3. Distribute. Okay. Subtract the 3x over on this side. Add this 3 over, so I get x equals 24. And when I go plug that back in, that works. Cool. Next up, again, don't have the same values. I want to look at the two numbers. Obviously 1 over 27 is smaller, but this is one where we just look at the whole numbers that we see, so 9 and 3. I go and I write out the powers of 9. 9 to the first is 9. 9 squared is 81. That's too big. Okay, so I'm going to need to think of a base that's smaller, that 9 and 27 will both be powers. So the first number that comes to my mind is 3. 3 to the first is 3. 3 squared. 9, perfect. 3 to the third is, wait for it, 27. Cool. So I got both numbers. Now I need to change both bases. So 3 squared to the w minus 8 equals 3 to the negative third, since this one is a fraction. Remember our fraction rules? Okay. Now we've got the same base, so I'm going to set these equal to each other, and I must multiply too. So 3 to the 2 times w minus 8 equals negative 3 times 2w. Cool. So 2w minus 16 equals negative 6w. So I want to go ahead and just subtract this 2w over. So I get negative 16 equals negative 8w, divide by negative 8, w equals 2. And go plug it back in. Looks like that one's going to work too. Okay. Now we've got an exponential only on one side and a number on the other. I want to make sure this is isolated with just its base and its exponent, and it is. So I'm good to go ahead and set up a log to solve. Log base 8 of 48 equals n minus 5. Type this in my calculator by just typing in log 48 divided by log 8. Watch those parentheses. Log 48, close parenthesis, divided by log 8. 1.86 equals n minus 5. I know I got a plus 5 over, so n's going to end up being 6.86. Okay, I need exponent and its, base and its exponent on the side by itself. I can't have that 2 and I can't have the 11. I'll move the 11 first. So 2 times 3 to the 4th y equals 72. Then I'm going to divide this 2 out front, because again, I cannot have that over there. 3 to the 4y equals 72 divided by 2, which is 36. Now I can set up my log. Log base 3 of 36 equals 4y. Type that left side in my calculator, log of 36, close parenthesis, divided by log of 3. And I get 3.2618 equals 4y. Divide by 4. And y is going to end up being around 0.815. Okay. Already isolated for me. This is a base of e though, so I know this one needs to be a natural log. Natural log of 65. Just hit that natural log button on your calculator, type 65, hit enter. 4.174 equals a plus 1. Subtract 1, and I get 3.174. Cool. And 40, gotta have this guy by itself. I'll add the 7 over first. Negative 34 plus 7 is negative 27. Divide this negative 3 next. I know that that's just gonna be 9. Okay, now I'm ready to set up my natural log. Natural log of 9 equals 2m minus 5. The natural log of 9 is around 2.197. Add 5 to that. Divide that by 2. And I get around 3.599, we'll call it. All right, so that is how we do solving. So make sure we're good on how to do those. Let me know if you have questions. Next up are those formula problems. Okay, you will have the formulas that you can use for your advantage. How we're going to set these up. Make sure you watch for keywords. Okay, that's the big thing. So number 41, she invested into an account that's increasing by 2.3%. Write a function to model this and then find it after 15 years. So we know that that's going to be growth. Okay, if it says increasing, it means growth. So we'll plug in that initial value times 1 plus the rate to the t power. So it should be set up just like that. And when you go and you type that in, you should end up with $7,032.42 when you round. Okay. Baseball card, $200 in 1980, another increase one. And then they're not giving us years, but they're saying find the value in 2016 if it was valued in 1980. So we just need to subtract those two values. 2016 minus 1980 is 36. So write that out if you need to write that out so you remember it. So 36 is going to be that t value. So when I go and I type that in, I end up with $2,284.79. Okay, another function one. Investing into a retirement account earns interest, keyword right here, compounded by monthly. Now we search, do we see the word continuously compounded? No, we do not. So we know we're just using the compound interest, the basic compound interest formula. So A is going to equal that initial investment times 1 plus my growth rate. Again, we always convert percentages to decimals, so make sure we do that. Times the amount of times compounded per year. Well, if it's bi-monthly, that means 24, okay? That means twice a month, so 2 times 12 is going to be 24. So we'll put that here. And we'll also put it up here, 24 times 25 years, and times t. And when you type that into your calculator, you should get $3,763.31. So make sure we get that one set up properly, okay? Then we've got Sarah taking out a loan at 4% interest to put a new pool in her backyard. That sounds fun. If the interest is compounded quarterly, so again, keyword compounded, write a function. I don't see the word continuous, so I know this one's going to be similar to the last one. So $30,000, 1 plus 0.4 over how many times per year? If it's quarterly, that means 4 to the 4 times 12 year. And when I type that in, I get $617.44. And I typed that wrong in my calculator, so make sure you don't do what I just did. When you type in that caret and you type in this exponent, you've got to put that in parentheses, okay? So instead, what I should have gotten, and what I just got when I typed it in this time, was $48,366.78. That makes a lot more sense, okay? So when you do that, we're not quite done yet. The question asks us on this one, it doesn't ask us for the balance, it asks us for the interest. So this would be our balance after the 12 years has passed, right? That would be our loan balance. But they want to know just how much interest, so I just need to subtract the $30,000 from that, okay? So $48,366.78 minus $30,000 is just going to be, we'll just go ahead and write that out just so we have it, okay? When you subtract that, you're going to get $18,366.78. So that would be your answer, okay? So make sure you read the question on these. The biggest thing is just reading through, finding those keywords, figuring out what you're supposed to do, okay? So 45 now, parents want you to have $50,000. They want you to have $50,000 to pay for your college on your 18th birthday. When you were born, they found an account that would pay 5.2% annual interest compounded monthly. How much money did they need to deposit in order to reach this goal? Okay, so this one's kind of asking for something different. So make sure, again, that you read through the question. They are wanting to know, how am I going to get you $50,000 in the end, okay? How much do I need to invest right here, okay? How much principal do I need to invest right here in order for this total to be $50,000? So then you'll just plug in everything else, and again, this is just a plain old compound interest one. compounded monthly, which just means 12. And then it says 18th birthday, so that's 18 years after you were born, okay? And again, make sure we type that in parentheses when we do evaluate that. So now we're solving an actual equation here. So what I'm gonna do is I'm gonna plug in and just simplify the parts that I do know. So I could type this whole thing into my calculator and figure out what number that is. So I'll do parenthesis 1 plus 0.052 divided by 12, close parentheses, caret, parenthesis 12 times 18, and I get around 2.5446. So this is 50,000 equals P times 2.5. I need to use a different color because that's hard to see. 2.5446P. Okay, so then I just need to divide this over. So 50,000 divided by 2.5446, and P is going to be about $19,649.45. Cool. Okay. You'll notice I must have rounded a little bit differently than what the key says, because it says 37 cents. Okay, I'm off by a few cents, but that's okay. It's just going to depend on how you rounded it for what your answer is going to be. All right, almost done. 36. Flu virus is infecting St. Louis. Continuous, keyword, growth rate is 6% per day. 30,000 people are infected. How many people will be infected in 1 week? Okay. So, continuous compound interest formula, that's what we've got to use here. Our starting amount is 30,000 today. So that's going to be P. E to the R times T power, so the rate is 0.06, and it says in 1 week. So we want to look at the compound rate. So it says that it's growing 6% per day. So since that is our compound rate, we need to convert this 1 week time into that time that it gives us for the rate. So per day, so if we're doing 1 week, that is 7 days. So that's going to be our time for this one. So let me know if you have questions on that. But again, look at what the compound rate is, what the unit is. So here it's per day. So convert your questions to days, okay? So when I go to type that in, type in 30,000, e to the 0.06 times 7, and I end up with, I'm going to round it to the whole number just because I can't have a decimal of a person. So 45,659 people is what we'll call that. Okay. We'll label that way. Whoa. There we go. Okay. How long until 100,000 people are infected? So it's asking how long, which means I am solving for time. Okay. So 100,000 people are infected. I know that that's going to be what my equation is supposed to equal. I know I still have a principal of 30,000, and then e to the 0.06 times, and we can just call this t because we're solving for time. So now we solve this. We need to divide this 30,000 over, because again I need my e with its power on a side by itself. So 100,000 divided by 30,000, lots of zeros, right? We end up with 3.3. So we're going to go ahead and set up this equation. I'm going to go over here so I have a little bit more room. 3.3 equals e to the 0.06 t power. This is an e base, so I know I need to set up a natural log. So natural log of 3.3 equals 0.06 t. Type in natural log 3.3 in my calculator. I get 1.19 with a big long decimal. I'm just going to go ahead and divide that by 0.06 while it's in there. And I end up with t equals 19.898. I'm going to call it 899. And this is in days, sorry. Cool. You could round that up to 20 if you wanted to, okay? And then lastly, we're almost done. You purchased a car for $30,000. This time it's depreciating at an annual rate of $15,000. How much is the car worth in 5 years? So this one is an exponential decay one. So 30,000 is that initial investment. 1 minus that rate, so 0.15. And then we take that to the T power. And when you type that in, you should get $13,311.16. That is it. All right, let me know if you have any questions. That is your review. And here's that answer key, so if you need to pause the video and check, but we should have gotten all of them correct here. Thank you.